Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at a past paper, the first of the 2020 IGCSE past paper, May-June 2020, paper 21. This is new syllabus now that we're into, and notice it's an hour and a half long, and I've already worked it out and would like to go through and explain it for you. Here in this first one, sorry, it's a little bit fuzzy. It says rectangular, this rectangular block A measures 3 centimeters by 8 centimeters. So 3 wide by 8 long. 5 rectangles are put together to make the shape. So you can see 1, 2, 3, 4, and 5. And so by calculating, it says work out the perimeter of this shape. So notice you have 8 long by 3 wide. So if it's 8 long and you are up against a 3 wide, that leaves 5 left over for the side. Then you have 8 long, and you work all the way around doing that. So notice that you have 1, 2, 3, 4, 5, 6 lengths of 8. You have 1, 2, 3, 4, 5, 6 lengths of 3. You don't count the ones that are on the inside. And then you have 1, 2, 3, 4 lengths of 5. I didn't count them as 2.5. I just counted them as 5. And then you get 48 plus 18 plus 20 equals 86. Question number 2, find the highest odd number that is a factor of 60 and a factor of 90. Well, 60 breaks down to 2 times 30, 2 times 15, 3 times 5. 90 breaks down to 2 times 45, 3 times 15, 3 times 5. So when you're looking at the highest odd number factor, it's not just the 5, but you can also have a 3 times 5 are common to both, which is 15. So the highest odd number would be 15, not the highest prime odd number, but the highest odd factor, which would be 15. Question number 3, Mrs. Solomon gives her class 2 math test. The scatter diagram shows information about the marks each student scored. So here you have the first math test along the bottom, second math test along the side, with all of these different scores. Write down the highest mark scored on test number 1. The test number 1 is right up here. You follow that down with your straight edge, you get to 66. Write down the type of correlation. If it's going in the upward direction, that's positive. If it's going downward, it's negative. And if it's kind of circular, then there's no correlation. So this one is going up. So like slope is positive slope, it's positive correlation. Draw a line of best fit. So you want to make sure that your line is roughly in the middle. So if you notice there were about, I forget how many students, you can add them up and divide by 2. So you should have roughly half your marks on one side and roughly half on the other. And try to keep it in the middle. So this is where I put it. Then it says, Hamish scored a mark of 40 on test 1. He was absent for test 2. Use your line of best fit to estimate for his mark on test 2. So test 1 was a 40. So if I draw 40 up to, from this test 1 up to this line of best fit, then an approximation for his second score would be a 48. And they allow a window between 46 to 50, meaning your line could have been a little bit up or a little bit down. This is about the window that you have for your line going through of best fit. Question 4, a bag contains blue, red, yellow, and green balls only. Balls taken from the bag at random. Table shows some information about the probabilities. Complete the table. Well, remember all your probabilities have to add up to 1. So 1 minus these other listed ones gives you 0.22 for the remaining one. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. Find out how many times he expects to take a red ball. Well, red is a 0.2, so if you do this 200 times, 0.2 times 200 would give you an expectation of 40 red balls. Find the nth term of a sequence, or the nth term of a sequence is 60 minus 8n. Find the largest number in this sequence. Well, you should notice that the bigger the number, the more you're subtracting. So that means your lowest possible value for n is 1, meaning 60 minus 8 is 52. 52 would be the largest number in the sequence, meaning your first number is the largest number, gives you a value of 52 in the sequence, because the more n is, the more you're subtracting and the smaller your numbers get. So that's just kind of a thinking it through kind of thing. Here are the first 5 terms of a different sequence, 12, 19, 26, 33, and 70. You can see that this is a arithmetic sequence of a difference of positive 7. You add 7 to each one. So find an expression for the nth term. So a to the n equals a1, that's 12, plus n minus 1 times d. D is the difference, which is a positive 7. Distribute that, you get 7n minus 7. 12 minus 7 is 5. So you get a to the n equals 7n plus 5 for your expression for the nth term. Here's a diagram with 2 angles provided. Now notice these are parallel. This one over here is not parallel to the other side, but these 2 are. So if you have parallel lines cut by a transversal, then that means alternate interior angles are equal. So parallel lines cut by a transversal, alternate interior angles are equal. So this one is the same as down here. And these 2 create a straight line, meaning they add up to 180. In other words, they're supplementary. So make that into an equation equal to 180. Solve for x, x equals 7. Down here, they give us these prime factorizations of 234 and 1,872. So then if you multiply the 2 together, you get 438,048. Use this information to do a product of prime factors for the 438,048. Well, that just means we're combining our prime factors of those 2 factors. So when you multiply like bases, you add the exponents. So 1 plus 4 gives us 5 for the factor of 2. 2 plus 2 gives us 4 for the factors of 3. And 1 plus 1 gives us 2 for the factors of 13. That then is our prime factorization for the 438,048. Question number 8, without using a calculator, work out these fractions here. So this is a mixed number, so 2 times 3 is 6 plus 1 is 7. So now we have 7/3 minus 7/8 times 6/25. Here we need a common denominator. So this one needs multiplied by 8. This one needs multiplied top and bottom by 3. That gives us 56/24 minus 21/24, which is 35/24 times the 6/25. And you can do some simplification there, cancel top and bottom, leaving you with 7/20 as your simplified reduced fraction. Factorize completely. So what you want to look for is what number divides out and what exponent can subtract out. So 21 and 28 are divisible by 7. You have an a that can be subtracted out from both. So 21 divided by 7 is 3. A squared minus 1 leaves you just an a. 28 divided by 7 is 4. And if you subtract out an A, that only leaves you a B left. And so this is your monomial factoring result here. Down here, we see a binomial with a subtraction in between. So most likely that's going to be a difference of squares. First, look for the monomial factoring. Is there anything that can factor out first? Yes, there is. There's a 5 that can factor out. So that leaves you with a 4x squared minus 9y squared on the inside. Now we can reduce those to squares. 4 is 2 squared, 9 is 3 squared. Then you can change it into a difference of squares where you have 2x plus 3y and 2x minus 3y. Don't forget the 5 out front. So this is your fully factorized factorization here. 5, 2x plus 3y, 2x minus 3y, and because this was a difference of squares. Now here we are looking at angles, and we have this 110 is a central angle. We have this x is an inscribed angle. Inscribed angles are half of the central angle when they open up to the same arc. So here your central angle opens up to here and here. Your inscribed angle opens to the same thing. So that means your x is half of the 110, which is 55. Up here you have an inscribed angle of 24 that opens up to the E and to the D. And your y is also an inscribed angle that opens up also to the E and to the D. That means they are the same value. So y is the same as 24 degrees. They're both inscribed angles that open to the same arc. Down here we have a speed time graph or velocity time graph, and it's asking for the total distance. And total distance on a velocity time graph is the area underneath the curve. So we can break this up into 2 areas, a trapezoid and a rectangle. So the area 1 is a trapezoid, 1/2 your 2 sides, so it's 6 and 12, and then the height is 30. So 1/2 your 2 base 1 is 6, base 12, base 2 is 12. That's these over here, the bases, and the height is 30. That gives you area of 270. Then the area for our rectangle is 12 high and 90 minus 30 or 60 long. So 60 times 12 is 720. You add those together and get a total area of 990. So that is your distance, 990 meters. Moving on to here, we have our box and whisker plot. They provide one box and whisker for you. They say find the interquartile range of the times taken for the children to complete the puzzle. So here is your minimum, here is your first quartile, here is your medium, this here is your third quartile, and then your maximum. So interquartile range is your third quartile minus your first quartile. Q3 minus Q1. Q3 is at 70. Q1 is down here at 48. So 70 minus 48 is 22. 22 is how far it is from Q1 to Q3, your interquartile range. Here it gives you your 5 summary number for adults. Minimum Q1, median Q2, or Q3, sorry, medium is Q2, upper quartile is Q3, and maximum. So it wants you to draw a box and whisker plot for the adults. So you just take these, here's your 28, here's your 42, here is your 58, here is your 70, and here is your 75. So there you have a box and whisker plot for the adults. Moving on here we have similar triangles. How do we know they're similar? Well, they both share the same angle here in the corner. These are both 90 degrees. How do we know this is 90 degrees? Well, this out here is an inscribed angle that opens to the diameter. And when you have an inscribed angle that opens to the diameter, it means it's 90 degrees. So since these are parallel, means this is also 90 degrees. So if these two triangles share two of the three angles, it means they share all three angles, meaning they are similar. So you can set up a proportion here. There's two ways to do it. You can either do one side of one triangle with the same side of the other, or you can do a triangle within itself. So here I did 13.5 of the one triangle is proportional to the 18, as the 21 is proportional to the whole length, which I called x. Or you could have done 13.5 over 21 and then 18 over x. So there's two ways of setting it up. You can either do one triangle to the other, or you can do the triangle within itself and then set it equal to the same ratio for the other triangle. So I chose to do 13.5 to 18 is 21 to x. Cross multiply, solve, you get x equals 28. So the full length of AC is 28. Then, because this is a right triangle, we can do, for this big one, because we want to find the radius, so we can do the Pythagorean Theorem to get the whole diameter. So our 18 squared plus 28 squared square root gives a diameter of 33.28, and then divide it by 2 to find the radius, gives us 16.6. Moving on to functions, here we have a composite function, f of g of x, meaning we put our g of x into f. So we put the 5x minus 4 into the f function, gives us 4 times the 5x minus 4. Don't forget the plus 3 at the end. This is equal to the 20x plus p. So here, distributing this gives us 20. I simplified this first. So 20x minus 16 plus the 3 simplifies to 20x minus 13. That then set equal to the 20x plus p. And then solve for x and your p, or sorry, get rid of your x from both sides. And then your p equals a negative 13. Here we have find the inverse function of our h of x. So that means to remember your function can be replaced with y. So your first step is to switch your x and your y. After you switch x and y, your second step then is to solve for y, or make y the subject. So multiply by 3, then add the 1 to the other side, so that 5y equals 3x plus 1. Then divide by 5, and don't forget to rewrite it into function notation or inverse function notation. The inverse h of x is now equal to 3x plus 1 over 5. So switch x and y, solve for y, that's your inverse function. Moving down here, I realized when I look at this later, I made a mistake in my marking. So I'll explain it here. First off, angle PQR is x degrees because it says that QR bisects PQB. So since it bisects it, that means these two angles are the same. So PQR is x, and this is x, because this bisects it. QR bisects that angle. So this is correct. Now the second part is not correct. The answer ends up being correct, but I didn't mark it correctly. QR, this arc, QR should actually be 2x. I didn't write 2x, I just wrote x. Why is that? Well, this here is an inscribed angle. And if you looked up inscribed angle, even when an inscribed angle is extended to a tangent, as long as your vertex is at the tangent point, then this still functions as an inscribed angle. And an inscribed angle is half of the arc. So I should have put 2x because x is half of 2x, but I just put x here. Not sure what I was thinking. I even wrote it QR equals x. Should be 2x out here. Then notice this inscribed angle opens to the same place, to Q and to R. That means if this is 2x, this would be half of that, which is x. So angle BQR is an inscribed angle. It doesn't equal the arc. It is equal to half the arc. So this should have been, again, 2x. And then angle QPR is x because it is half of that same arc. So I didn't do that right in my marking. This should be a 2x. This one here should be a 2x. And this should be equal to half the arc. In central angles are equal to the arc. Okay, we don't have a central angle. Central angles are equal to the arc, but inscribed angles are equal to half the arc. In other words, you multiply the inscribed angle by 2 to get the arc, and the inscribed angle is half of that. So sorry for the incorrect notations there. Not sure what I was thinking, but it does come down to be a correct answer. You show that it is an isosceles triangle because these two have the same value, and this one cannot have the same value because it's told us that x is less than 60. So it can't be equilateral, therefore it has to be isosceles. Number 16, here we have a proportional, direct or inverse. This one happens to be inverse. So when it's inverse, m equals k divided by what follows. If it's directly, it would be k multiplied by. So since this is inverse, it's k divided by. And it says the square of p minus 1, not the square root. It says the square. So that's p minus 1 squared. And the first set of numbers is 4 and 5. So we plug 4 and 5 into it. 4 minus 1 is 3, squared is 9, multiplied to the other side gives us a k of 45. We rewrite our formula, so m equals 45 over p minus 1 squared. Then we put in the 6 for our second set of numbers. 6 minus 1 is 5, squared is 25. So m equals 45 divided by 25, which reduces down to 1.8. You could put 9/5 or 1.8. Moving on to vectors. Here we have a column vector, 5, 7, and it wants us to multiply it by a scalar of 3. So you just simply multiply 3 into both of the vector components. And so the x component is 15, 3 times 5 is 15, 3 times 7 is 21. That's the y component. So we get a column vector of 15, 21. Then it wants us to find these brackets here, or actually absolute value signs, means in vectors, it means to find the magnitude of the vector. So basically, finding the magnitude of the vector is same thing as doing the Pythagorean theorem. So the 10 is your x component, 10 squared, negative 24 is the y component. So a squared plus b squared equals c squared, square root. And so when you work that out on your calculator, you get a 26. 26 is the magnitude of the vector that goes directly from v to w. The column vector gives you the x and y components on how to get there. So it means over 10, down 24, but the magnitude would be 26. You might recognize this as a multiple of the 5, 12, 13 triplet. Remember your 5, 12, 13 triplet or any multiple of it. So you might have recognized it as a 5, 12, 13, and you just times it by 2 and you get 26 for your answer there. Now moving down here to our vector diagram, gives us this parallelogram, says that OA is P and OC is Q. E is the point such that AE and EB is a 3-to-1 ratio. 3-to-1 ratio. Find OE in terms of P and Q in its simplest form. So if we want to find OE, we can just draw in a line straight there. So that means we have to go, to get to E, we have to go from O to A, and then from A over to E. So OA plus AE. Do your general formula first to figure out how to get there. Then plug in the parts. So OA is P, AE is 3 out of the 4 of this long one, which is Q. Q is AB, is the same as OC. So all of this is Q. So AE is 3 out of the 4 parts of Q. So then you have P plus 3/4 Q as your answer. Here is a upper lower bound question. Says the perimeter is equal to 2 times the width plus the height. The width is 12, correct to the nearest whole number, and the height is 4, correct to the nearest whole number. So that means the first layer that you do for bounds is to find your upper and lower bound for each specific number. So 12 would have a lower bound of 11.5, an upper bound of 12.5. 4 would have an upper bound of 4.5 and a lower bound of 3.5. Now work out the upper bound of the perimeter. So this gives us our second layer is the formula. And of course, to find the upper bound means we want to maximize the formula. And the way that this is set up, we want the bigger numbers because they are adding. So we use 12.5 and 4.5, calculate that out. So we get a upper bound of 34 for the perimeter. Now on to question 19. Here we have this prism, rectangular prism. It shows this cuboid, A, B, C, D, E, F, G, length 20, width 5.5. It does not give us the height, but it does give us the volume. So we can calculate the height here first, because width times length times height gives you volume, 495. So we can calculate the height to be 4.5. Now it wants the angle between AG and the base. Well, if you draw this line here, then the line below it would be AC. AC would be the line below it. So we want to find the angle between those two, between AG and the base of the cuboid. So first we need to find out this AC, which is the hypotenuse of the base. The hypotenuse of this 5.5 and 20. So we use our Pythagorean theorem to solve for that, and we get a hypotenuse of 20.742. We already have the height. Now we can use our Sekolah because we have a right angle over here, and we're going to use tangent because from our angle we have opposite and adjacent. So tan theta equals opposite 4.5 over the adjacent 20.742. We do the inverse tangent and make sure your angle is in degrees, your calculator is in degree mode, and you get 12.24. And in Cambridge, you just need 1 decimal for degrees, so 12.2 degrees for that angle. Number 20, the curve y equals x squared minus 2x plus 1 is drawn on a grid. They don't show it to you, but they tell it to you. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 equals 0. What does that mean? If you have 2 separate graphs that intersect and they're being used to solve for this, this other equation, then that means these 2 graphs are components of this equation here. So they don't give us the line. We have to come up with the line, but they do give us the curve. So what we want to do is we want to basically kind of like subtract out this curve, or we want to say we want this curve to be on the left-hand side and then see what we need to have on the right-hand side, because if the two are equal, then that means they intersect. If they're equal, that means you're looking for their intersecting points, which they already did to find this. So if this is one side, notice the x squared is already there. To get to a negative 2x, you need to add 5x. So you do that to both sides. You add 5x, it makes it negative 2x. Then to get a 1, you need to subtract 4. 5 minus 4 is 1. So that gives you the curve graph. And then what you have on the other side, the plus 5x minus 4, that is your line. So what you're doing is you're decomposing a more complicated equation into two simpler equations. One of them had already been drawn on the grid for you. Then you can use the line, which is easy to graph, on top of this graph, and where the two intersect are your answers for this one up here. So it's just breaking down a complicated graph into two simpler graphs and then using graphing to solve it. So here's your equation of the line. Now expand and simplify. So you have three binomial terms here, or factors. So I just factored the first two. X times x is x squared. 3 times negative 5 is negative 15. A negative 3x plus 5, or 3x, a negative 5x plus 3x is a negative 2x. So these front two multiply out to x squared minus 2x minus 15. Then I put the 3x minus 1 on the bottom, and I did it just like you do basic math with negative 1 times negative 15 is 15, negative 1 times negative 2x is positive 2x, negative 1 times x squared is negative x squared. Put a 0. 3x times negative 15 is negative 45x. Notice maintaining your place values. Here's your constants, here's your x's, here's your x squareds, here's your x cubed. Just like you do in basic math, you have your ones, tens, and hundreds. Here you have your constants, your first degree and second degree. So 3x times negative 15 is negative 45x. 3x times negative 2 is negative 6x squared. And 3x times x squared is 3x cubed. Then you add your like terms. Here's 15, negative 45x plus 2x is a negative 43x. Negative 6x squared and a negative x squared make a negative 7x squared. And you just have your 3x cubed. Put all those together, and there is your expanded form for this, expansion. 3x cubed minus 7x squared minus 43x plus 15. Moving on, find the area of a regular hexagon with side of length 7.4. So a hexagon means you have 6 sides. It also means you have 6 equal, because it's regular, triangles. So if you take 360 degrees, which would be your circle around the middle, divide it by 6, then that means each of your central angles are 60. And it says that the sides are length 7.4. And so you can figure out that if the sides are length 7.4, and this is 60, and the sides are the same, that means the angles are the same. And you can figure out that this is actually an equilateral triangle. Doesn't have to be, but it happens to be here because of this being 60. These sides are both the same, therefore the angles are the same, which means they also have to be 60 as well. So you have this equilateral triangle, and you can use your trig formula for the area, which is 1/2 AB sine the angle in between. So 1/2 7.4 times 7.4 times sine of the angle that are in between those. And so you get 23.71. Again, make sure your calculator's in degree mode. And because there are 6 of these, multiply by 6, and that gives you 142 centimeters squared as your area. And that's the end of our paper 2. Paper 2, zone 1. So hope that this helps. And again, thank you for joining me in the Zoom room. Look forward to seeing you again next time, where we'll look at paper 4, zone 1. And that is the end. Thanks again for joining.